So, hello everyone, welcome to our event. This event is brought to you by Data Talks Club, which is a community of people who love data. We have weekly events. This event is one of such events. If you want to find out more about the events we have, you can go to a link in the description, click on this link and you'll see all the events we have in our schedule. Do not forget to subscribe to our YouTube channel. This way you will know about all our new videos, and then join our amazing Slack community where you can hang out with like-minded people. So during today's workshop, you can ask any question you want. There is a link in the live chat. So just click on this link and ask your questions, and we will be covering these questions. Do you prefer questions at the end or during the workshop?
It can be between as well.
Okay,
Helps
so
to clarify.
then if a question is relevant to what you're showing, I will ask it in between. Okay, so with that, let me stop sharing my screen. Emmanuel, the floor is yours.
Awesome. Thank you, Alexei.
Yeah,
Thanks for having me.
thanks for joining.
My pleasure. I will share my screen and let's see if it's visible. Then we can get started.
Okay, probably wrong button. So Emmanuel has disappeared. Hopefully he comes back soon. Maybe he wanted to share his screen and then accidentally left. Was it wrong button or?
It was this first time sharing screen on Zoom. I just downloaded the app, so some technical issues.
I see. At least you didn't have to reboot.
Yeah, that's a good thing. So I hope we can see my screen right now.
Yes, I can see a screen.
Awesome. Yeah, thanks for this opportunity, Alexei. I've been following the Data Talks community for a while, and it's been doing fantastic job bringing people together, sharing great knowledge. And Alexei has been very actively engaging the community, so great job there. And
Yeah, thanks for being a part of this and answering our questions about your book.
awesome, thank you. So today we'll be looking at load testing ML services for robustness and scalability. And I think in the ML community, there's been a lot of talks around machine learning ops, automating data workload. You hear me now?
Yes, I was just checking if it's something with my headphones or.
uh, Zoom technical issues, but hopefully we can proceed now. So yeah, we
Yeah.
will talk around these topics around ML ops and especially load testing microservices for robustness and scalability before we take it to production. So before I jump into the main topics around this, I'll give a quick intro about myself, just a minute. So we know each other a bit better. So I'm Emmanuel Raj. I'm coming from Finland, but you can see that I'm not in Finland. It's very sunny and a good place here. I'm in Spain right now, but I'm coming from Finland. I work there as a lead machine learning engineer at Relex. It's a cool company based in Finland. We do cool stuff. Do check it out. And I'm also a machine learning researcher with interest in doing research on MLOps, edge computing, natural language processing, computer vision, and blockchain. The main interest is to find solutions to these big problems. So that's why I tend to have my hands on research as well. And also last year, I published a book called Engineering MLOps. The reason I wrote this book was there was a lot of interest for people to learn about machine learning ops. And I thought it's a great opportunity when the publishers approached me to write this book. So here it is. It's a very hands-on book. Um, Aimed at intermediate level. So if you're a beginner, I would say there's some learning to do, but also it covers some basic topics for you to get started. So it's very hands-on, teaches end-to-end for MLOps. So do check it out. So we'll see some snippets from it as well. today. But moving on to the topic, just wanted to have a common language between us, cutting out the fluff when people talk about artificial intelligence. Um, it's easier to define it this way, going ahead in the presentation. So I see artificial intelligence as simply data fit into machine learning with human in the loop. So this is what artificial intelligence can be simplified to. The reason we are doing this right now is to understand what is machine learning ops and how is it helping us in today's day-to-day life. So when it comes to software engineers, we are working with DevOps, and DevOps had this challenge that it didn't help us to bring together this machine learning capabilities to production. And that is the reason we have MLOps. So MLOps is DevOps together with artificial intelligence, which we saw earlier, data plus ML plus human in the loop. So this is just to understand a common understanding between us as we go through the presentation and the workshop. Now let's jump into the topic of load testing and why we are here today. So before we go in depth, it helps to look at the background on the high level. So in order to make machine learning models, we need data and code, and when these both go together, there's a training process. We use compute, we use code, we fit the right data and extract a model out of it. And of course, in this process, there's a human involved in the loop as well. This is what we're doing. And the challenge with simple traditional DevOps is that it doesn't help to bring both together, because what happens in a lot of organizations is data is developed in one angle, like it's growing exponentially, and we have code, we are trying to tie the data together and manage the data together. But in the end, what happens is we start having data in silos, and the data starts going exponentially in one direction and the code starts going in another direction. So this is the problem we are faced, and MLOps brings this solution to this problem as it ties together everything with data, code, and all the necessary things related to machine learning operations. So with MLOps, we can have data and code going in the right direction together with end-to-end lineage, and so we can backtrack at any point and find answers to our questions for related to business in any company. So this is what MLOps does on the high level. But before we delve into our load testing topic, it's worth to look at the MLOps workflow and where this load testing is useful in this workflow and why is it important. So this is a snapshot from my book. So here we have MLOps workflow. It's a modular workflow. It has three modules. One is the build module, the second is the deploy module, and then third is the monitor module. So in the build module, we have the machine learning pipeline where we ingest the data, we version the data, ingest the data, extract the features, and then in the second step, we train the model. Then we test the model, we validate it using different methodologies. One can be cross-validation, and there are a couple of other methods to do that. Also, then we package the model after we test the model in various formats that we can serialize. And then after we package the model, we can register or containerize the model and have them stored somewhere so that we can do quick deployments in the deployment phase. In the deployment phase, we have application testing phase, which is what we are going to look at today when it comes to load testing. So in the application testing phase, we can do various testing such as integration testing, load testing, uh, shadow testing, A/B testing, and whatever is relevant for your business case. So this phase is very important when we want to ensure the robustness and scalability for our ML solutions. So we'll be looking at application testing today. And then after everything is okay, we take it to production, take the model to production, we deploy the model, and then the monitor module comes into play where we monitor the performance in real time. We analyze the data, we look for local and global explanations. And after we get the local and global explanations, we can have event-based triggers. If, for example, the model drift or data drift is not working as we planned out to, then we can govern the system. We can have certain actions to make sure that there's another model deployed or a right action taken to ensure that the business goals are reached. So this is in detail there are 5 different drivers that drive the MLOps workflow. If we look in detail, there is data, code, artifacts, middleware, and infrastructure. This is just for our information. We might not go much in detail today. I recommend checking out the book, and also there are many resources around this. So in order to understand how all this works together, it will be helpful to do that. But today, what we're interested is in the application testing, especially the load test, to ensure that the microservices we build are robust and scalable enough. Yes or not? If yes, then we can pass it on to production. If no, then we have to work on it further. So without further ado, let's jump into the core of it, the load testing. And in order to do the load testing, we'll have some hands-on stuff that we'll do today. So just take a minute to digest this picture. I tried to make it as simple as possible for us. So here, we'll check out a fast API based microservice, which predicts whether if it rains or not, as simple as that. So this is also one of the hypothetical use cases from the engineering MLOps book, where we take a real life case, we replicate or simulate a case at a port, a harbor, to predict if it rains or not, because there are ships coming at the harbor and there are logistics being delivered. So the port is trying to manage the logistics efficiently. So predicting weather helps them to plan things in advance. So that is the idea behind this kind of a service here. Also, this can be used for weather updates and many other use cases, the weather prediction module. So we'll keep it simple today. We'll just see the model in play if it predicts rain or not rain. It's a binary classifier. It's a fast API based service, and we'll containerize it using Docker. And we'll do this locally for simplicity. I'm not deploying it anywhere in a Kubernetes cluster or any other deployment target for simplicity. You can do that and test it in the same way. I will explain how. But then we'll also use a service called locust.io, which is a load testing framework. It's an open source load testing framework. Comes with Python SDKs as well. So we can nicely tie it up in our MLOps workflow as well. So at this point, I'll take a pause before I jump into the code. Are there any questions or comments so far, Alexei?
Taking a look. No, I don't see anything, neither in live chat nor in Slido.
All right. So let's jump into the code then. Do you see my Visual Studio?
I can see it, but can you make it larger, the font? It's quite small. Maybe just hit Ctrl X or what you have on Mac, CMD. Not Ctrl X, Ctrl plus.
Control plus, yeah. It works.
Yeah, like that. Yeah.
Yeah, maybe like this we can manage. So as we saw in the image, there are 2 main modules that we'll be looking into. One is the fast API microservice, which predicts the weather. And the second is the load testing module, which helps us to test the robustness and scalability of this microservice before we deploy it to production. So first, let's have a quick run through for this microservice very fast so that we understand what's happening. It uses fast API to create microservices. So we are creating a fast API object here. Then we have a scaler to scale the incoming data, because we need to have it in a proper scale in order to infer to the model. Here we are using a support vector machine, a support vector classifier. This is pre-trained, and it is serialized in open neural network exchange format. It's a nice format for interoperability. We can exchange the models in different formats. So it helps in that. And so we are loading the support vector classifier model. And then we have created a predict endpoint within the fast API service, where we are inputting data such as temperature, humidity, wind speed, visibility, pressure, millibar, current weather condition, and these kind of input data, and trying to predict in the future, 8 hours afterwards, what is going to be the weather condition like. Is it going to rain or not? So we basically scale the input data after we fetch the input data from predict endpoint, and then we make the prediction. We know that if it's a rain or no rain situation. So for now, I will spin up this microservice. So I've built the Docker image. So the Docker is simple here. It's using this FastAPI's image, and then we're copying the app, which we just saw, installing all the requirements needed, and exposing the microservice at port 80. So this is how the Docker file works. And I have already built the Docker image because it takes time to load, takes around 5 minutes. So I'll run the Docker container.
Can you also make this larger? I don't know if it's actually possible in terminal. Does Control Plus work?
Control Plus, it does work. Yes.
Yeah, that's more visible.
Yes.
But
So,
you have now less space on your screen. Sorry.
yeah, maybe I can clear the screen here and it might be better, hopefully.
So now you want to run this thing, right?
Yes. On port 80, I will run this, map it to my port 80 on the local machine, and we'll do the inference from that port. So I have built the Docker image and tagged it as FastAPI, something like this. So now it should be running. Okay. Let's see.
Something is running already on that port.
Yeah, something. Maybe I've run it earlier. Yeah, it's running already. So I've run it in the background, and it has this predict endpoint as we saw earlier. In this, we can just pass the data that we want to pass as input data. So just for a sample, I have some sample data here that we could just dump and test if it works or not.
So FastAPI comes with this UI, right?
Yeah, it comes with this UI. It's pretty cool actually for testing.
Swagger, right? Or what is that?
It's Swagger. I think they have inbuilt Swagger in it.
That's super cool.
Yeah. So after we do the inference, we see that the response is 200, and it says that it will rain. So the microservice is working fine. And we'll test this microservice now. See if it is robust and scalable to go forward or not.
There is a question if, so this code is publicly available, right?
I can make it publicly available after.
It is not yet. Okay.
Okay, yes.
Okay. Yeah. Clear. So there is a question if there is a link to the code. So it will be made available.
Yes.
I will put this in the description of the video.
So now the next task is to spin up the load testing module. So load testing, we do it with locust.io. I'm trying to make it a bit big. So probably you can see. So I'll run up through the code now. So it's a simple Python script. It is using Locust. Here we are importing functions from Locust such as HTTP user, task, and between. HTTP user is a main function that simulates users. We can mention how many users we want to simulate. For example, 10 or 50 or 100, whatever we want. So here we have to mention the test data, the JSON dump that we want to push to the endpoint that we want to test. And then we have to mention the header type. It's a JSON. Here we have to define a class, whatever name we want to have, we can have, and then pass this object HTTP user. And then we are defining a function inside to make a post call to our endpoint. That's what we're doing. It's very straightforward, this one. And we will start to spin the local server for Locust, local service for locust.io in my PC as well. So Yes, this should do it.
Does it always have to be with capital L?
It can be with small l also, I think.
Okay. So I noticed that it's capital.
Yes, it's a good point. If it's not, then it's can be confusing.
Okay, so what is happening right now? So it's starting a web interface.
Setting up a service at this port 8089. So we can see that port in the browser. It has a UI as well for us to test and get all the statistics. It also comes with SDK where you can get the statistics without UI in your terminal or in your service where you're inferring. So here we'll simulate the number of users. For example, we can say, I want to simulate 40 users per second, 40 users. And then this is the spawn rate. For every second, how many users should like start acting till the max 40 hits. So we can say, let's start by having 10 users per second. And we have to define here our endpoint. So once we have the endpoint here, this instead of localhost, if you deploy it on Kubernetes cluster or deployment of your choice, you need to provide the address for it. So the endpoint would be the same, of course, predict in this case. Then we spin up, we start swarming. So this means that there are 3 fails. We can see why the service is failing. We are making like 148 requests so far, 200 requests so far. So every second there are requests happening, and the number of users are spawned up to the max. There are 5 failures. We can see why it is happening. So here in this chart, it shows the number of requests per second, 13 requests per second. As you can see, that is like the norm here. And then we can see the failures, how many failures are happening per second. So this is kind of like the statistics we're getting real time. And the response time also we can know how many seconds it's taking. And then we can see the simulation. It took 10 users for 1 second. The next second it even spin up more. So you can see the progression in spawning up, and there are 40 users, and we can see the failures.
Why it became faster? So with the response time was 130 milliseconds, but as more users came in and started sending requests, I would expect that it would actually become slower, but it became faster.
Yeah, that's an interesting observation. Needs investigation. So
Okay.
you see these
Which
kind
is
of
a good thing, I guess.
yeah, it's a good thing because maybe it takes time to get stabilized, this service.
Yeah, right.
And then it just runs in the memory, and it's faster. That might be one of the reasons.
And do you know why these failures happen right now?
Yeah, that is something very interesting. Let's see why it is happening. So we can see the reasons. There are 4 failures for internal server error. So there was some internal error in the microservice. So we can go and check the logs for that to be sure. And then there was a remote disconnect. I guess this is something to do with the port that we opened up. So since we are running it locally, we can expect this kind of remote disconnected kind of errors, but this should not happen in production. And also we need investigation in this. It's good that there are some errors coming so that we can see the features of this locust.io. So also we can look at the exceptions and also download the data, share it across your organization, and talk to your other engineers and find solutions. So after you have tested enough, you can stop. So there is no limit.
There's a question. So the question is about monitoring resource usage with Locust. So Locust does not show you the resource usage, right? So for that, you need to use a different tool like Grafana, right?
Right. It doesn't show resource usage. It just monitors the endpoint and it simulates users. Yeah. So that's why we have to use this in this situation. We can't use it in production. This is just to stress test and know if your service is robust or scalable as per your requirements. So what we mean by robust is it working fine with the number of requests per second? And what we mean by scalable is if you have like 1,000 users that need to be served every second, as we spawn the number of users per second, is it scaling enough? Is your load balancer working fine, or your auto scaling working fine, or however you've defined your scalability, is that working fine? If yes or no, then you know the answer to it. That's where we use this service. So it gives us
Yeah,
a cool.
there is, sorry for keeping interrupting you. There is another question which is related to scalability, although it's more about scaling FastAPI locally. So the question is it possible to run many FastAPIs on one machine? So
It is.
something like, uh-huh.
It is possible. You need to have this load balancing mechanism in place for that. So you can spin up multiple containers and have an endpoint where you can balance the traffic and orchestrate the workloads. So Kubernetes can be helpful, for example, to
Mhm,
run locally. The same
mhm.
principles what we do on the cloud as well. You can do in locally.
Yeah, so we can use something like Kind or Minikube or something like this to run it locally, right?
Yes, that can be used. Yeah, so I found this very interesting as an add-on in our CI/CD pipelines. When we do the testing, we can have like these checks within the CI/CD, especially for the continuous deployment, to check the robustness. If it is serving X number of requests per second, yes, then if yes, then pass the test. If no, then it needs investigation. So the product owner or uh, machine learning engineers can look into it, investigate it, and make it better, and then pass it on to the next phase. So can be valuable practice there.
So what is the pipeline? So first, I guess you deploy to staging, and then you start hitting this staging endpoint with load testing, right? And then if everything is fine, you promote this to production.
Exactly, that's how it goes. So this is the
Okay.
staging environment here, application testing phase.
Hmm. And do you also do something like this during, well, when the thing is already on production? Like, I don't know, maybe at night when there is not a lot of users.
Usually we don't test in the production. It depends on the business case, of course, if they want to test. So that's why we have the staging environment where we
Hmm.
replicate the real life like situations, and we bombard the endpoint with X number of users. So this is where this comes into picture. But in production, it should ideally work as we expect. That's why we have this load
Hmm.
testing in place.
Yeah, so you will have a real load testing from real users, right, in production.
Yeah, exactly. That's how it goes. So yeah, I think this is how it brings value to the whole workflow of MLOps. And for more information, check out the book. There are detailed steps how to implement it, and there's much more information. And I think that's basically what I had for today. But if we have any questions, we can take it.
Yeah, there are questions. So one question is, would you recommend FastAPI as opposed to other machine learning specific tools such as BentoML, TouchServe, etc. for production?
Hmm. I would definitely suggest this as one of the top picks. I can't say about those because I haven't tested them myself. Fast API has been gaining good traction, and especially it's been designed for production-based workloads, production kind of microservices. I think it's easier to configure than Flask, for example. That's something I've commonly used, but there are other competing frameworks as mentioned. So I can only say when I test it. I would rather not say it otherwise.
Yeah, I usually go with Flask API, but more and more of my colleagues now prefer Fast API than Flask.
I see.
And it's actually nice that it has Swagger built in. Then I think the API is a bit cleaner, so you just say app.post and that's it. So you don't need to use
Exactly.
this method equals post like in Slack and then like in Flask.
Exactly.
Uh,
And
I Yeah, sorry.
in Flask, we have this development server, production server. We have
Yeah,
to
right.
upgrade it using Gunicorn and all this. So there is some plumbing work to do underneath, but with Fast API, it's a bit easier.
But you also need to, I saw you use the U VCorn or how it's called, like also
Yeah,
VSJ, some
it uses
VSJ.
underneath. It uses underneath in the container, but it configures very like it's automated, this part.
Okay, I want to share my screen because there are some questions on Slido. It's probably simpler if I just share my screen so you can also see them. So, okay, now let me share my screen. Yeah, so the first question is how similar this Locust to a DDoS attack. Can we actually use the Locust to DDoS somebody?
I think we can replicate the DDoS attack using Locust. It's a nice thought.
Yeah, maybe you can just use it to test your competitors, right?
Can be, but that's where we need to also investigate into securing our endpoints as well. We should not expose it to everyone. Maybe we use some VNets to restrict access and do such things, but it's a good thought. It can be done using Locust.
And when it comes to machine learning, at least, this is something you usually have internally, right? So this is not a customer-facing service. Usually some other application uses this, right? So it means that it's deployed maybe to your Kubernetes cluster as an internal service. And then you also put Locust as a service in Kubernetes, right? And then you use that to test internal services, right? Is it
That
how
can be
it's
one way.
deployed usually?
Yeah, that can be one way to do it, or otherwise you can deploy your service in Kubernetes cluster, but then you can have a mini service running inside your CI/CD pipelines. So
Oh,
there
yeah.
you can run this. It's a very light server, the Locust. It doesn't take much memory, so
Okay.
that is also one place to run it.
Okay. Do machine learning cloud providers have similar load test tools like SageMaker, Azure, etc.?
At least for Azure, I can comment that it doesn't have. So I think the companies are looking into this area. In the future, we might have this kind of feature, which is quite useful as well. And my guess is SageMaker might not have it also, as far as I've seen.
Well, I think these are more. It's not specific to machine learning, right? So it's more generic. It's for general software engineering.
It is an
So
engineering focused task, but very
probably you.
important one as well, actually, for
Mhm.
MLOps.
Of course, it is important, but what I'm trying to say is maybe Azure has it, but not specific for machine learning. Or I'm not sure about Azure, but let's say if you are talking about AWS, maybe you should, instead of looking for load testing SageMaker, maybe you should be looking for load testing AWS, right? And then maybe they
Can be.
have a more specific tool. I have no idea. I'm just saying that yeah, maybe you need to have like to widen your search a bit.
It can be, yeah. They might have different services that might be suitable for this kind of tasks as well.
But do you think it should be specific to machine learning? Maybe some of the parts should be specific to machine learning in this case, or it's still quite generic?
I think generic tools can manage the job, but having something for machine learning, and especially to replicate this kind of security attacks as well, where we see that criminals or the bad actors are bombarding the machine with certain inferences and trying to decode the model performance and trying to like influence the model in a certain way. So these kind of things can be probably tested using other machine learning focused tools. Can be good to have such things.
I think I'm muted, right? I was saying that I think there is a tool called Selden, and there are things that are called explainers. So they use some sort of, they're trying to explain how the output of a model looks like, but they are also trying to sort of mimic these attacks that you were saying. So maybe if they could be used at a higher scale, instead of sending one request, you can send 10 or 100. This could be this sort of load testing, right?
Reverse engineering the models and
Mhm.
hacking them. That's what those guys are doing. So
Okay. So another question is using Locust and FastAPI at the same machine efficient? Locust will use the same resources like API as well. This should be, thus should we use Locust on another machine?
Good question. So just for demo purpose, I'm running it on the same machine. So don't do this in production systems and your workflows. Ideally, as we were discussing with Alexi, one way to do it is running these services in Kubernetes cluster and isolating these containers and services and using them like that. And the second way is to have the locust running as part of your continuous deployment pipeline, where you have it as a phase, or a job, a cron job, which is spun inside a small server within the CI/CD pipeline, and then you have your microservice deployed on Kubernetes, for example. So that is these are some ideal ways to do it.
Thank you. What do you think about Django? Is it good for machine learning projects?
I've always been a fan of Django because I started out as web developer. It's a really nice framework. I think it's good enough for ML projects. There's nothing that is like a roadblocker. It has all the features where you can define your custom functions. You can always load your serialized files. You can do the machine learning inference. I don't see anything stopping us from doing that. It's only that machine learning engineers or data scientists, we are not so into web development. So maybe that's why Django didn't pick up that much speed, but Django is approved.
I think maybe the reason we do not see a wide adoption of Django in machine learning is because it has quite a few features. Right? In addition to just creating an endpoint that can be used for serving the models, it comes with a lot more features.
Right.
Like, this ORM, I don't know, admin panel and all these things that are usually not needed for machine learning projects.
Exactly. It's more for like this full stack web development, but it can be used for machine learning. Yes.
Yeah, and I saw some projects, not at the company where I work. I saw some projects so for people for their portfolio. So some of them develop their portfolio projects with Django, because yeah, if you're already a Python developer, you know Django probably, and then you can just unpickle your model there and use it. So why
Yeah.
not?
Yeah. Why not? Exactly.
What do you think about JMeter or K6?
I have used JMeter. It can be used as a replacement for Locust, of course. But K6, I'm not sure. I haven't used it. But yeah, there are other alternatives for Locust. Locust is just one open source service, so we used it for this session. But definitely do let us know if you know any other services that work as a substitute or which are much better, probably.
I think JMeter is more popular in the JVM world, in Java world,
Right,
because
it is.
it's written in Java, and I guess Java devs would just prefer it because it's easier for them to run it, to check the code, right? And Locust is a Python tool, right?
Exactly. Uh, Locust is for Python developers.
It doesn't mean it cannot be used for load testing Java services, right? It can. It's
It
just
can. Yeah,
yeah.
it's just about picking the right tools for our problem and making ourselves more efficient. So that's how it goes.
So let me check if we have any questions in live chat that I missed. Yeah, so there is a comment from Ankit that they use FastAPI for their text-to-speech model. It's pretty fast and support is also good. And multi-process support is also good. Okay, I don't see any questions, so which means I think that we covered all the questions. So thanks a lot for, let me stop. I'll stop sharing my screen. So thanks a lot for joining us from sunny Spain. And
Thank you, Alex.
yeah, so you're probably on vacation now, right? So thanks for
Actually,
finding
remote work,
time.
remote
Remote.
setup. So with Relax, my company, we are flexible to work. So I thought, why
Mhm.
not just escape the cold for a while from Finland?
Yeah, well, at least you, instead of spending time on a beach, which probably is still a bit cold, right, because it's winter, but you still found time to teach us a bit of. Actually, there is another thing. Anyways, yeah. So thanks for finding time, and yeah, maybe let me share my screen. So I don't know if it makes sense to you why you have fails on your CLI. Do you know what this question is about?
When you tested FastAPI, API, those are some warnings that I was getting because I'm using this Apple M1 chip. Um, because I'm using the FastAPI image, and they are not like really well synced to run on M1 chip. At least what I tested. They might have other images that it's just throwing some warnings. But good observation there.
Mhm. Yeah, I also have a computer with ARM architecture, and
Hmm.
it's painful.
It is. This is ARM architecture as well, and
Mhm.
it hurts a while. Takes some time to get past some things.
Yeah, maybe it's good if you're an Android developer or iOS developer, but if you're a machine learning engineer, maybe it's a bit difficult, right?
Yeah, that's what I noticed now with the M1 chips. But hopefully it gets a bit better. Um, and that's how the adoption goes, right? Apple does something, or Microsoft does something, or Amazon does something, and the world follows. So
Mhm.
hope the developers are watching these problems.
I'm trying to stop the stream, but the questions keep coming. So, are you working on MLOps course in Udemy?
Yes, actually, I've been working on MLOps video course along with the
Ah, nice.
yeah. It's gonna come out somewhere in March.
Okay.
That's the plan.
So now you're practicing your video editing skills, are you not?
Somewhat, yeah.
That's somewhat okay. So March, right?
Yeah, March. That's my birthday month. So birthday
Okay.
present.
Okay. Well, we're all looking forward to seeing your course there. So please share a link with us. And
Definitely.
thanks again for joining us today. Thanks everyone for joining us today as well and asking questions. That was super useful. And yeah, looking forward to seeing you again.
Thank you, Alexei. Thanks for having me. It's always a pleasure to come on the community and talk. Thank you.
Yeah, thank you.